Hello again, and welcome to the third video of this series demonstrating and testing Apocalyptica. In this video, I will highlight how collisions occur and how limiting algorithms prevent certain actions from occurring. In the first test, I will create situations where each individual game object will collide and see how the program conducts these collisions. For the final test, I will demonstrate the limiting algorithms behind zombie attacks, projectiles, and attempt to force a zombie out of the game window. Okay, as you can see, I've loaded up a game, and I am on the second wave with three zombies. Excuse me, I'm just going to kill this this walker here, just for a second. So, first things first, let's attempt to test each of these individual projectiles. So, each captain will fire two different types of projectiles. The first one right here, the one that is following me right now, is the swarm bomb. The swarm bomb has does no damage to me when I get hit by it. Excuse me, but it will result in every single screamer coming to my location and attempting to attack me. As you can see, I'm going to let the scream bomb hit me, and as you can see, there is no damage. But with this other rocket that is being fired, this is the normal rocket projectile. This normal rocket projectile has a 1.5 second fuse and will blow up if it doesn't reach me. However, if the collision is detected here, if I go over to this and it detects a collision, it should do damage. It does 2 damage, so it should take roughly about, depending on how much health I've got, I'm afraid I can't see directly, but I can see the amount of hearts I've got. It should do it in either up to 3 collisions. So there's 1 collision, that's 2 damage. And there you go, you can see I've been damaged by the heart going down. Now, of course, each player has a specific projectile, which, as you can see, perfectly collides with the zombie classes. And now we're going to see how, when these two zombies collide, how they will what will result when these two collide with each other. As you can see, this zombie is colliding with the other one, and you may have just seen it there. It pushes it back so that it does not overlap with the zombie's collision box. And that is working as tested. This is part of a separation algorithm I've created. Okay, so in the following tests, I'm going to, well, as you can see, the zombie here is being separated from the other zombie, so that is a perfect test for a captain colliding with a captain. So now, I'm going to kill this other zombie. Okay, no, actually, perfect. So I can now use I'm now going to place a breakpoint for the next zombie to attack me. Ooh. There we go. Okay, cool. I'm going to kill one of these zombies, as we've already seen the separation algorithm. Oh, should be one more. What? Give me a second, sorry. Forgive me. These zombies seem to be dodging and weaving. There we go. Okay. So now, I forgot this does 2 damage. This does very little amount of damage. So, I'm now going to place a breakpoint into my code to detect when a collision has occurred, and I will show you the code executing. I've placed the breakpoint, and now I'm going to let the zombie come and collide with me. And there we go. So, in the code here, we have a list of all the collidables that are possibly... Oh, sorry, that was a reminder for me for later. I have now fixed that because it turns out that I was actually colliding twice. So, in this list, you can see the 2 collidables. So we've got the ninja and the walker. As we can see, they're both there. So now, if we take the collidable that is being chosen, in this case is the walker. The walker's collision box, which is this, is then checked by intersecting it with all of the other collidables in this list. Of course, there is only the ninja in this list. Therefore, as these collision boxes collide, as you can see, the collision box would be about here-ish, and you would see the top corner of the collision box is colliding here. I'm afraid I do not have a visual representation of it. You can see as these have this has detected a collision, and now if I go inside of this collision, this should call the collided method. So now inside of this collided method, we use the name of the iCollidable, and we will then check. Oh, whoops! Oh no. I will now go back inside that. Sorry. Oh, I'm going to quickly do that again so I can go and see it again. Sorry. Press the wrong button. And now we will check the name of the collidable. So if we check the name here, I don't know if it'll let me check it here. Okay, so the name of the target, so as we know, the collidable is the ninja here. So it should go to... It shouldn't detect anything on this end, because as it's the zombie, it doesn't need to actually damage the player. It actually just causes damage to go to the player, so it skips through. And yeah, perfect. So that is how the collisions are detected. Of course, this collision method is slightly inefficient, and I've talked about, and I will be talking about this in my evaluation section. About how I can minimize the, as you can see, there's a large area that isn't actually part of the collision, but is causing collision nevertheless. Therefore, I will be talking about this inside of my evaluation. Excuse me. Now, if I continue the run here, sorry, I forgot I have to take the breakpoint off. I will now kill this zombie here. Oh, there we go. And then I'm going to clear this wave so that we can see the next couple of zombies. So specifically the screamer zombies. And oh yeah, I've figured out the strategies, luckily. And hopefully we can see the screamers in action. Okay, so continuing from where we were, we now have a screamer in the mix. Now this is the perfect example for the scream bomb. As you can see, I'm going to let the captain fire another one just so you see that it wasn't a fluke. If a collision is detected with the swarm bomb, it will result in the position of the screamer's desired location being changed to that position, and thus it goes to that location. If I get damaged again by it, well, I won't take damage, but if I collide with it again, it will result in the screamer going there. Now, if I collide with the screamer, it will do damage. So let me just kill this this captain here. There we go. He is dead. Okay, perfect. So now that the screamer is all on its own, I can now show you that we take damage when I collide with it. So if I go anywhere near it, it will do damage to me after its kill cooldown. That is a failed test. Okay, so what should happen is the screamer should attack the player after a certain cooldown, but it seems as if the collider is having trouble. I have been noticing this also. The collider, due to being such a time-sensitive, class, has resulted to zombies not actually colliding with each other, which has been a problem because of the video editing software that I'm using here. So it might be due to that, but for the sake that it isn't, I'm going to class this as a failed test. Either way, as we can see, the collision method that I'm using works for this simple game, but for a more complex game, it would need a more accurate collision method, and thus I'll be talking about that in my evaluation. Okay, so for next set of tests, I'm going to attempt to move outside of the screen, and as you can see, I'm going to be pressing the A button. I'm going to go up, going to go down, going to go right. I'm unable to leave the bounds of the screen, as you can see. I'm unable to leave the bounds of the screen. and this is due to a limiting algorithm that I've placed on the properties, specifically on the position of the player class. Now, this is not solely limited to the player class. It's also this also extends to the zombie class. Zombie classes have a limit on their position so that they can only go a certain distance outside of the box. So, for example, as you can see, I'm placing sufficient enough pressure on this character here for him to move upwards, but also this captain uses the flee method, which the flee steering algorithm, which I will be going into detail in the next video and the final video. But this character cannot move outside of the bounds of the game, even though I'm pressuring them right here. So I'm going to quickly run away from that. Okay. And of course, if I let this zombie here collide with me and kill me, okay, it was colliding before. Please forgive me. I'm going to do a quick little test on my end. Okay, I'm back. I have fixed the error. It seems to have been a little bit of a weird problem, but I believe I've fixed the collision method, so it should result in my character taking damage. I have checked over my code, and it seems to be working in perfect order, so it should be detecting these collisions. Thus, I can only rule this down. I can rule this down to collisions not being detected due to the video recording software providing too much strength on too much pressure on my hardware. I'm afraid I can't provide any more than that. Of course, I can provide the code. All the implementation will be on GitHub and will be in the documentation. So, well, there's a collision. Okay, I'm going to close this down. As I said, I have to draw the conclusion that the software that I'm using is limiting my hardware output, and thus collisions are not working fully, not working 90% of the time. I can promise you that collisions will work fully due to the fact that I can go through my code here and say that this code has worked before these recordings, and will work afterwards. But I can only say that if validation needs to be made, please check my GitHub for this code. Thank you very much for watching. The next video will be the next and final video will be on how each steering behavior is implemented and which zombies implement these. Also, we will be talking briefly and do a little bit of deep dive into how waves are generated and how the boss zombies are created. Thank you very much.